Here in our last video for this week, and for the course, by the way, we're going to talk about the software exploits and remediation on the developer side of security for mobile devices. First of all, there's an organization called the OWASP, the Open Web Application Security Project, and they have identified 10 top mobile risks. I'm not going to read this list because it's in your book, and you can read it for yourself in the book near the end of chapter 13. One thing the book does not mention, so this is kind of an extra here, is the OWASP site has several tools available for learning to penetrate insecure web applications, including one called Juice Shop, which is a website that purposely has a lot of bugs in it, a lot of insecurities, and they step you through a learning process in learning how to attack it. I have a screenshot here of several tools that they have. One is this link to Juice Shop. This is just a screenshot, so I can't click it and go there. But Juice Shop is a website that is set up for you to attack. They also have some other tools, Net Attacker, an automated network scanner built for vulnerability detection, and so on. You can read through these tools. These are all available on owasp.org, and this is a screenshot. This is the home site where these are listed. All right, let's go through several, and some of these match the ones that you saw up here in these top 10 types of mobile attacks here. And these all are about the developer, or what the developer did do or didn't do correctly. So one thing the developer may do incorrectly is to have weak server security. The paragraph in the book is a little unclear to me, as I wrote here. Here's what it's trying to say. That if a server is insecure, then it can be exploited by an attacker to deliver malicious code. Now, it almost sounds in the book like it's saying that the web server or the administrator of the web server is the attacker. That's not what it's saying. It's just saying if your web server has weak security, then the bad guy can use that to attack you. Unsecure data storage. Well, if data storage best practices are not followed, data may be stolen easily. Top of page 292, there's a list of 9 best practices, and I'm not going to go through them here, but you can read those on your own. 9 best practices to make sure your data storage is secure. All right, next is insufficient SSL and TLS transport layer protection. Now remember that SSL and TLS are what we call transport layer encryption schemes, and they are used during web page trading. In other words, when you see HTTPS, that means it's being encrypted, usually by these protocols. Also during certificate transfers, SSL and TLS is used during authentication, say on a WPA2 enterprise system. SSL and TLS are involved in that. A website can require secure HTTPS authentication, but then switch over to insecure HTTP format. Now, when this happens, of course, everything can happen, or anything can happen. HTTP is all plain text, nothing's encrypted, and on page 292 you'll see some best practices that should be followed to avoid this. Data leakage. Now, unlike unsecure data storage, we're talking about a different kind of data leakage here. We're talking about app developers that don't secure where and how your app data is stored on your device. If the developer is sloppy about how data is stored on your device, whether it's encrypted or in plain text, where it's put on the device, is it easily accessible, can it easily cross over to another app, and so on, then that is a problem. Again, this is on the developer's shoulders, but you should be aware. Poor authentication methods on apps. If the author of the app does not use good secure authentication methods, then of course we have a problem. Broken cryptography. So at some point realize that anything that's encrypted has to be decrypted. So it's decrypted usually after it reaches the device. But since our devices are on many kinds of communication systems, Bluetooth, Wi-Fi, cell system, and so on, then there is an opportunity that an app developer can create an app that can load malicious code to your device if your device is not properly secured. For example, if you jailbreak the device. Client-side injection. Some people try code injection techniques, and it's on the developer's shoulder to do input validation. For example, if a phone number belongs in a form, it should not accept code, for example. So that's one of the ways that the developer is responsible for keeping things secure. Untrusted inputs. So data can be sent and received across multiple inputs and outputs, which offers attackers pre-authorized access to transmitted data. What do we mean by all of that? Well, we mean that if you are connected to a network, you're already pre-authorized, or you're logged on to your bank, for example. Now you are pre-authorized, and because your phone is capable of multiple kinds of inputs and outputs, both Wi-Fi and cell and so on, then we have possible untrusted input or output to that bank or whatever it is that you're logged on to, the network, the bank, or whatever. So using proper sandboxing of apps during development, and of course, permission choices by the user can also help if you do not allow your app to access certain areas that it wants to access. And those come up on your phone. You have the option of disallowing access to certain things, like your contact list, for example. So by doing that from the user side, you're also helping to protect it. Session hijacking. Well, it turns out that session hijacking is not very difficult to start with, and it's even less difficult on mobile devices. Apps running in the background, for example, on a phone, continue to run in the background. Now, it's not like your Windows machine where apps leave memory when you're not using them. Your phone actually stays full all the time. The RAM in your phone stays in use constantly, and it just kind of drops old stuff off the back end as new stuff is put there. And so that leaves a lot of things running in the background. That can allow the bad guy to see the session IDs and perhaps steal those session IDs. Finally, lack of binary protection. So developers, of course, need to follow secure coding techniques to make sure that they're binaries, in other words, executables is what binary means, to make sure that they can't be modified or analyzed. So that's a lot on the developer's shoulders. Some of it's on your shoulders as well, to be aware of what developers are doing and to be aware of the possibilities and make sure you do your part to keep yourself safe. Now that's the end of the chapter and that's the end of the course. Thanks for being here.